Skill 5.5 Use models to explain expansion and contraction of matter during these processes. S. Conceptualization SS. Critical thinking, hands-on learning, problem-solving objective. Utilize models to provide explanations for the expansion and contraction of matter in different processes. Instructions. Scan the given QR code to access the worksheet named as Modeling Matters Transformations and solve it. 3. Evaporation. Evaporation and boiling are similar processes. The difference is that in boiling, the liquid is heated. You might have observed that if you leave water uncovered in sunlight on a sunny day, it soon disappears. The wet clothes dry in less time in the open air. Where does the water go? How does it happen? The water absorbs the heat from the sun. The particles of water become warmer. Warmer particles move fast and leave the surface of the water. Thus, the water begins to convert into gas. Water in the form of gas is called water vapors. The conversion of a liquid into vapors without the involvement of heat is called evaporation. The equation given below shows the phase change in evaporation. Evaporation continues at all temperatures. The humidity in the air is due to evaporation. Liquid gas. Condensation, on the other hand, when water vapors touch a cold surface, they transfer their energy to the cool surface. As a result, the motion of the particles becomes slow. The slow-moving particles come close to each other. The gas again changes into its liquid state. It is called condensation. For example, the droplets of water that appear outside the cold glass surface are the result of condensation of water vapors. Gas-liquid. Figure 5.4 Water droplets outside the cold glass. The other example of condensation is the water droplets that appear at the underside of the lid of the hot pan as shown in figure 5.5. The temperature at which a gas changes into its liquid state is called its condensation point. 5. Sublimation. You often have seen mothballs in your wardrobe that disappear soon. They do not disappear, they change into a gas. Sublimation is a change in state in which a solid substance directly changes into a gaseous or vapor phase without passing through the liquid state. Solid gas. A few of the substances have the ability to sublime, such as naphthalene and camphor. Skills 5.6 to 5.10. Investigate the factors which affect the rate of evaporation and communicate findings. Choose equipment to carry out scientific investigations to measure the temperature during the heating or cooling of a substance and communicate findings. Make predictions of likely outcomes for a scientific inquiry. Interpret results using scientific knowledge and understanding. Draw conclusions from their findings. Objective: to understand and visualize how particles behave and arrange themselves in solids, liquids, and gases using a particle model of matter. Instructions: scan the given QR code to access the worksheet named as Matter Mysteries, Unveiling Particle Behavior, and solve it. Skills 5.11 to 5.12. Use the particle model to identify changes in melting, freezing, evaporation, condensation, and sublimation. Relate the changes in states of matter with real-life situations. Objective: utilize particle models to accurately identify and differentiate changes in states of matter, including melting, freezing, evaporation, condensation, and sublimation in various real-world scenarios. Instructions: scan the given QR code to access the worksheet named as Modeling Matters Transformations, and solve it. Activity 4. Start heating water and find out boiling point of water with help of thermometer. Answer the following observation. Did the temperature become constant when water start boiling? What was the boiling temperature of water? Why the bubbles came out from the surface of water while it's boiling? Can you find the difference between boiling and evaporation? Hint: when a liquid reaches its boiling point, its temperature on a thermometer will remain constant. Supervised activity: make flashcards, photographs, slideshow to show examples of change in states of water, e.g., clouds and snow, windows with frost, water boiling in a pot, etc. Ask students identify state in each process. Knowledge 5.4 Diffusion and Particle Theory. Place an open bottle of perfume in a corner of the room. Soon you will feel the fragrance all over the room. Dip the tea bag in a hot cup of tea. Soon it will dissolve throughout the cup. How do these phenomena happen? Both processes are known as diffusion. Diffusion is defined as the movement of particles from an area of higher concentration to an area of lower concentration without the involvement of external energy. In the above examples, some of the particles of perfume and tea leaves escaped and moved across the available space, i.e., room and cup of tea, respectively. On their journey, they collide with particles of air and water respectively. The same happens with drops of food color and paint when we dissolve them in water. The release of carbon dioxide from soda drinks is also an example of diffusion. Scan the QR code given on page 54 for more understanding. Skill 5.13 Make observations about phenomena related to diffusion around them. Objective: to make detailed observations of various phenomena related to diffusion in their surroundings, and they will develop the ability to explain these observations using the concept of diffusion. Instructions: scan the given QR code to access the worksheet named as Exploring Diffusion, Observations in Everyday Life, and solve it. Activity 1. Investigate the factors affecting rate of evaporation. Study question: does evaporation rate remain the same throughout at all temperatures and in all conditions? Materials required: 4 handkerchief piece of cloth of similar stuff and size, water, watch procedure. Label the pieces of cloth as 1 to 4. Dip all the pieces of cloth into water and gently squeeze. Place cloth 1 at a radiator heater. Hang the cloth 2 near the window. Hang the cloth 3 near the door. Hang cloth 4 near the fan on. Note the timing of each cloth placed. Note the timing when they dried. Calculate the difference in timing. Results: which cloth dried the fastest? Why? Which cloth dried the slowest? Why? How much time did the cloth placed near fan take to dry? Conclusion: which scientific process will you attribute to drying? What is the effect of air on drying? What is the effect of heat on drying? What is the effect of cold on drying? Deduce and enlist the factors affecting evaporation.